gecko feet, and super sticky tape. Geckos can scale walls and even hang upside down, all thanks to millions of microscopic hairs on their toes that create van der Waals forces, weak attractions that become powerful in numbers. Inspired by this natural trick, scientists developed dry adhesives that can hold a human's weight, detach cleanly, and work over and over. These materials now assist robots in climbing, anchor medical devices to skin, and even function in space where suction fails. It's nature's grip, reimagined for science, proving evolution is the ultimate engineer. Kingfisher beak and Shinkansen train. When Japan's bullet trains blasted out of tunnels, the sonic boom shook neighborhoods. Engineers turned to an unlikely muse, the kingfisher. This bird dives into water silently, thanks to its sleek beak. Inspired, they reshaped the train's nose to mimic it. The result? A quieter, faster, and more energy-efficient train. A bird's precise plunge transformed human transit, combining speed with silence. What began as an avian hunting technique now drives one of the world's most advanced transportation systems, with elegance borrowed straight from nature. Owl ears and silent technology. Owls fly with ghostly silence, sneaking up on prey without a sound. The secret? Asymmetrical ears and serrated feathers that break up airflow. Engineers studied this and applied the findings to drones, fan blades, and even wind turbines. The result? Machines that operate more quietly and efficiently. In aerospace, where stealth and noise matter, owl-inspired design is revolutionary. Nature's nocturnal hunter didn't just influence aviation, it reshaped it. Evolution fine-tuned these silent wings, and now they help modern technology glide under the radar. Shark skin and swimsuits. Shark skin isn't smooth. It's covered in tiny tooth-like scales called dermal denticles. These reduce drag and stop algae from clinging. Scientists copied this for swimwear that gives athletes an edge and for ship coatings that save massive amounts of fuel. The result is faster humans and cleaner vessels. From deep ocean predators to Olympic podiums and industrial shipping lanes, this scaly innovation proves that rough textures can lead to smooth performance. Nature's armor turned into a blueprint for speed and sustainability. Lotus leaf and self-cleaning surfaces. The lotus leaf stays pristine in muddy waters thanks to tiny bumps that repel water and dirt. Droplets roll off, picking up grime like miniature janitors. Scientists mimic this phenomenon to create self-cleaning surfaces on windows, solar panels, and buildings. No scrubbing, no chemicals, just smart design borrowed from a flower. The result is cleaner cities and more efficient energy with zero effort. Nature's effortless cleanliness offers a sustainable solution to one of humanity's oldest problems, keeping things clean. Butterfly wings and displays. Butterfly wings shimmer with brilliant colors, but not from pigment. They use nanostructures that bend and scatter light. Inspired by this, scientists developed energy-efficient displays that reflect vivid hues without constant backlighting. These screens use less power, look better in sunlight, and open doors to new tech like flexible e-paper. A butterfly's wing became a masterclass in optics, teaching engineers to play with light like nature does. What once fluttered through gardens now shapes how we view the digital world. Brightly, clearly, beautifully, fly eyes and panoramic cameras. A fly sees the world through hundreds of tiny lenses, capturing a near 360-degree view. This compound eye structure inspired panoramic and surveillance cameras used in drones, VR, and security systems. With multiple viewpoints combined, engineers created machines that see everything at once. From tiny insects to cutting-edge tech, this leap in vision reshapes how we record, explore, and protect. Nature's all-seeing eye found a second life in machines, letting us capture the full picture. No blind spots, no surprises. Ant hills and eco-buildings. African termite mounds regulate internal temperature using natural ventilation. No electricity, just clever design. Inspired by this, architects designed buildings like Zimbabwe's Eastgate Center to stay cool without air conditioning. The building breathes, cutting energy costs dramatically. This bio-inspired architecture brings sustainability to cities, using ancient insect wisdom. Nature's engineering, refined over millennia, now supports modern cactus spines and water collection. Cactus spines aren't just for defense, they help capture water. By guiding dew toward the plant's base, they turn air moisture into survival. Scientists copied this strategy to create water harvesting systems in arid regions. Using spine-like structures, these materials pull drinking water straight from the air. In deserts, where every drop counts, this passive technology could be life-saving. What began as a survival trick in harsh environments now inspires solutions for drought-stricken areas. Spider silk and strong materials. Spider silk is stronger than steel by weight, flexible, and biodegradable, a natural marvel. Engineers have replicated it for use in medical sutures, bulletproof vests, and even space tech. Some projects go further, using genetically modified goats that produce silk proteins in their milk. Nature's finest fiber has become a high-tech staple. From spider webs to laboratories, this evolutionary masterpiece now strengthens the tools that protect lives. It's a perfect balance of strength and grace, woven by spiders, perfected by science. Fish eyes and anti-glare glass. Fish see clearly underwater because their eyes minimize reflections using microscopic surface patterns. Engineers studied this and developed anti-glare coatings for glasses, lenses, and screens. These coatings cut glare, boost clarity, and work in bright environments where standard glass struggles. Thanks to aquatic adaptations, we now enjoy better vision on land and through our devices. It's a tiny solution with massive impact, turning watery insight into digital precision. The next time your screen looks crisp in sunlight, thank the fish. Desert beetle and water harvesting. The Namib desert beetle collects water from fog using bumps and grooves on its back that attract moisture. Inspired by this, scientists developed surfaces that pull drinking water from the air in desert climates. These tech materials don't need power, just smart texture. In places where water is scarce, this beetle's back became a life-saving template. A tiny insect survival hack now quenches thirst in harsh regions, proving once again that the smallest creatures can offer the biggest breakthroughs. Sea urchin and architecture. Sea urchin skeletons look fragile but are marvels of strength. Their porous structures distribute stress and resist breakage. Architects mimicked this design to create lightweight yet sturdy buildings, bridges, and domes. Less material, more resilience. This biomimicry reduces costs and environmental impact while boosting safety. Nature's delicate armor became a structural secret weapon. From ocean floor to urban skyline, the sea urchin's body plan turned into blueprints for the future. Fragile beauty in the wild, powerful performance in concrete and steel, sea sponge and fiber optics. Deep-sea sponges build intricate glassy skeletons that channel light efficiently. These spicules inspired new optical fibers that are tougher and more flexible than conventional ones. Useful in medicine and communications, they transmit data through twisting spaces without breaking. By studying these soft-bodied creatures, engineers enhanced how we send and receive information. The deep ocean's glow now runs through cables and clinics. Nature lit the path, and technology followed, with glass spun not by machines but by underwater architects, snakes, and infrared cameras. Some snakes can see heat. Pythons, for example, use specialized pits to detect warm-blooded prey in total darkness. Engineers use this trick to develop infrared cameras that see temperature instead of light. These are now essential in rescue missions, military operations, and nighttime security. From slithering hunters to high-tech tools, this gift of heat vision changed how we explore the dark. Nature gave snakes a sixth sense, and we borrowed it to save lives and illuminate the unseen. Subscribe right now. More videos are coming soon.